Solving special right triangles. So these two triangles that you see in this picture are 45, 45, 90 triangles, and the way that I know that is because the legs on this first one are marked as both being x. So I know that it's an isosceles right triangle, and if it's an isosceles right triangle, then it is a 45, 45, 90 triangle. Now, the way that I like to solve these 45, 45, 90 triangles is by using a table that kind of makes it like a pattern. So I write my rule for the 45, 45, 90s, and I write 45, 45, 90. The rule is x, x, x root 2. And in this case, on the picture, we have an 8 here, and it is across from the 90-degree angle. So we have an 8 across from the 90, so under the 90 I put 8. So this means that 8 is equal to x root 2. So 8 equals x root 2. So to get the x alone, we need to divide by root 2 on both sides. And so x would be 8 divided by root 2. But we can't leave a radical in the denominator. So we have to rationalize that, which means to multiply by that root over itself. Because we can multiply anything by 1 and it won't change the answer. And we can't leave the root, so what we do is, you know how it needs its buddy to get out of the radical, so you have its matching part here so that you have your pair. So when I multiply by this root 2 over 2, what I get is I get 8 root 2 divided by square root of 2 times square root of 2 is the square root of 4. And the square root of 4, we all know, is 2. So what I'm really looking at is 8 root 2 divided by 2. And the 8 and the 2 in this problem can reduce. 8 divided by 2 is 4, so the answer for root 2 is what x is. So now I have solved for x. So in the table, x is 4 root 2. And then since this is also x, it is also 4 root 2. So that means that the across from the 45s in my picture, I can label with 4 root 2. So both of those sides are across from the 45, so in this case, x is 4 root 2. Okay, on number 6, that one's easier actually. Again, I've got markings in my picture that tell me basically what this triangle is. It has angles marked as congruent, which means that the sides across from those angles are congruent. And so it's isosceles, and since it's isosceles, it's a 45, 45, 90 triangle. So again, I'm going to set up my table. And the rule, x, x, x root 2. And then in the picture, 5 root 2 is here. It is across from the 90-degree angle. So under the 90, I need to write 5 root 2. So 5 root 2 equals x root 2. So if 5 root 2 equals x root 2, and I divide by root 2 to get x alone, then the root 2's cancel on both sides, and then x is just 5. So in my table, x would be 5. And so that means that in the picture, across from the 45-degree angles, I can label that with 5. So I know that in this problem, x would be 5. And that's how you solve 45, 45, 90 triangles.